This is a tutorial intended for students in a class. It shows how to run an analysis of variance and multiple comparisons on SPSS. The scenario for this particular tutorial or example is shown here. Zoo researchers were interested in how much time gibbons spent playing with enrichment objects. The enrichment objects were added to an exhibit with a family of captive gibbons, male, female, and juvenile, and the amount of time spent with enrichment objects was recorded over several days. When you open up SPSS, you'll be presented with this screen here. There are two tabs on the bottom. The Data View tab is the one that we're looking at now, and then the Variable View tab is where you set up each of the variables, the information, but in this case, I already have my information in Excel, so I'm just going to go ahead and import the information from Excel. So I'm going to go up to File, Import Data, I'm going to select Excel, and I'm going to navigate to my Excel data, select Open, and it shows this screen here. So yes, I'm checking because I'm going to read the variable names from the first row of data as shown here. It's the correct worksheet. If you have multiple worksheets, you can actually select different worksheets. So this is the correct worksheet, and it looks like it's put everything in the right location. Everything's in a separate column. So I'm just going to go ahead and click OK. So it went ahead and imported all of the information. I have my date information here, the mean time that each of the individuals in the gibbon family spent playing with the enrichment objects, and then I have the different individuals, whether it's the juvenile, the amount of time the female spent, and also the amount of time the male spent. If there are dots here, I recommend getting rid of those. For some reason, it thought that there was data there, so I'm going to just highlight these two rows, right-click, and clear. Oops. So those are all clear now. Okay, so just to kind of show you how these are set up, if you go to the variable view, the variable names are the column headings of each of the columns that were on this data view. So the first one was date. The type of variable, I have it set up as date, and here are the selected format. And you always want to make sure that the type of variable matches the measure. So in this case, my date is a numerical variable, so I have a scale variable, as opposed to a categorical, which would be ordinal or nominal variables. The mean time that each individual spent playing with the enrichment objects is a numeric variable as well, so I can go ahead and leave that as numeric. And I can also indicate how many decimal places that I want. So it's fine set at 1. And again, I want to make sure that the measure matches the type of variable. So I have a scale variable here. And then finally, for the individuals, the male, female, and the juvenile, the type of variable is categorical. So I want to type in the text of the variable. And so categorical variables, if you want to type in names, would be you'd select the string variable here. And in this case, since it's a categorical variable, I want to make sure that the measure selected is not scale, but ordinal or nominal. So nominal works for me since there's no inherent order of those individuals. So that's all of the information that I've imported. I've just double-checked to make sure that all of the variables are set up correctly. To run the analysis of variance, you want to go up to Analyze, and you can do a compare means and do one-way ANOVA, but I don't suggest doing that. There's more flexibility if you run the analysis of variance using the general linear model. So select general linear model. Univariate is the equivalent of a one-way ANOVA for all intents and purposes for our case. So I'll select univariate. And then here I've got my different fields. So the dependent variable, or my response variable, in this case is the amount of time each individual spent playing with the enrichment objects. The fixed factor, this is the group, so juvenile, female versus male. The fixed factor is going to be the groups that you want to compare. So I'll select that. And date is not really relevant for my overall analysis, so I'm just going to leave that in that pane. So a couple of things that you want to look at. In this case, remember, an analysis of variance just tells you whether one of the groups, the mean amount of time spent with the enrichment objects, differs in just one of the groups. You would be able to reject your null, and so therefore you'd have a significant ANOVA. But what an analysis of variance doesn't do is it doesn't tell you which groups differ from which. So that's why you have to select the post hoc selection, and the factor that I want to make this what's called multiple comparisons is the groups. So I'm going to say do a post hoc test for the group and select Tukey, which is a really common post hoc multiple comparisons test that we run. And then I'm going to select continue. I also want to be able to see my descriptive statistics, so all of the mean values for the different groups. So I'm going to go ahead and select descriptive statistics. I'm going to also check here that my significance level is set at the conventional 0.05, and it'll provide confidence intervals at 95%. So that all looks good. Okay, so pretty much everything else looks fine. You could, if you wanted to do a plot, I'll just kind of show you. So plots, I could have separate lines showing for the plots, but in this case, we're just going to leave the plots out. Okay, so when you hit OK, you're going to be given an output, which is a slightly different file from the actual data sheet. If you go up to window here, you can see that this is my output and then this is my data sheet. So you can toggle between the two. The analysis of variance output looks like this. So here are my three different groups with the three different levels, females, juveniles, and males, and it tells you the sample size, or in this case, the number of days that I observed and recorded the amount of time spent with the enrichment objects. And then here is really important. You're given the means, standard deviations. So you can see the mean amount of time each individual spent playing with the enrichment object and their associated standard deviations. So the analysis of variance, the null hypothesis is that all of the means are equal, and the alternative is that at least one of the means differs. So the significance level then of interest is going to be the group. We want to know, does any of the individuals within the group differ from the others? And so we go across here, and I have my significance level, my significant value, which is my p-value, and it's 0.004, which is less than my significance level of 0.05. So I do have a significant analysis of variance result, meaning I would reject my null and conclude that yes, indeed, at least one of the individuals differs from the others. If I scroll down, this is where I have my multiple comparisons table, which is the Tukey results. And so here is where the multiple comparisons does every possible pairwise comparison within my groups. So it's comparing, for example, and just to double check, the dependent variable it's measuring is mean time. And so it's comparing my female versus my juvenile, and it's giving me the mean difference in time, and it's giving me a p-value. And so I can see here that the p-value again is less than 0.05, so therefore there was a significant difference between the time spent with enrichment objects between the female and the juvenile. And since the mean difference is taking I, which is the female, and subtracting from that j, which is the juvenile, I have a negative value here, meaning that the time spent with the juvenile was a larger value than the time spent with by the female. So that's why this is negative. If I were to flop these around and have juvenile here and female here, that would be this row here. And you can see it's the exact same value, but it's a positive value. So remember, I said that the p-value was less than 0.05, indicating it's significant. So you can see that there's an asterisk here. So pretty much any asterisk is going to indicate a significant value. So the other significant value is the male versus the juvenile. So here I've got, if I just look at the juvenile table section of the table, the juvenile versus the female is significant and the juvenile versus the male is significant. Both of these values are positive, indicating that the juvenile spent more time. And if I go back up here, I can see, yes, indeed, that is the case. And so these are my corresponding p-values. So the difference between the juvenile and the female, I have a p-value of 0.009. The difference between the juvenile and the male, I have a p-value of 0.023. And then in this last two columns is the 95% confidence interval. So this is giving me my lower and my upper bounds, showing where the true population difference may lie. This would be between these two bounds. There's also this homogeneous subsets. This lists the actual mean values, and subsets that are grouped together do not have a significant difference, whereas values that are in different subsets do have significant differences. So this tracks with what we saw in the multiple comparisons table, that the juvenile, having played on an average of 9.8 minutes with the enrichment objects, was much higher and significantly different from the males and the females.